Hello there, Mr. Sutton here, bringing you the Algebra 2 3-6 Part 1 homework solutions on quadratic inequalities in two variables. To graph this inequality, we're going to graph it like it's a normal parabola, only we're just going to be conscious of whether we need open dots or closed dots, dashed lines, closed lines, solid lines, all that stuff, and then we'll have to shade one direction or the other. So this is more or less standard form, so I'm going to use my negative b over 2a formula for finding the x value of the vertex. So that's going to be a negative invisible 0 over 2 times an invisible 1. So that comes out to 0. And then plugging that back in, we get 0 squared minus 9 for the y value of the vertex. So that's negative 9. So 0 comma negative 9. And that is down here. Okay, so in order to graph this, we need two more points. Now, I usually use the y-intercept if I have something in standard form, but the vertex and y-intercept are the same on this one. So what I'll do instead, there's a few options we have. One option would just be to plug a number that's close to the vertex, like 1, in for x, and get another point that way. Or, in this case, it's pretty easy just to set this thing equal to 0 and find the x-intercepts. So if I add 9 and then square root both sides, I get x equals plus or minus 3. So that gives me the x-intercepts now. We've got one at positive 3 and negative 3. And since I've got no equals here, I've been using open dots, you might have noticed. So I'm going to use a dashed line to go along with those. And then I'm just going to shade above the parabola because we have y greater than, so that means a shade above whatever the curve is. So there we go. For this problem, we're trying to graph this quadratic inequality. This is very much standard form, so let me use my negative b over 2a formula for finding x values of vertices. So that's going to be negative 9 over 2 times negative 2. This is negative 9 over negative 4. So that's going to be, let's see here, that's you could reduce it to just 9 over 4, or in order to actually more easily graph it, you probably want to turn that into 2.25. So let's go with that. Let me plug that back in now to the original here to get the y value of the vertex. So we have all of this with positive 2.25 plugged in, and I'm actually going to run that on Desmos because I don't feel like doing all of this in my head. So just to make sure I don't mess anything up, I'm going to write the original function here. So we've got negative 2x squared and then plus 9x minus 4. And then I'll just plug in 2.25 by doing f of 2.25, just to make sure I don't mess any parentheses up. So we've got 6.125. All right, so our vertex then, 2.25 comma 6.125. And boy, that looks ugly. So let's graph that out, and then we'll go from there. So I'm going to the right 2.25, which is about there, and up 6.125, which is like an eighth. So that's right about there, that area. And since I have solid, or I have an equals, I'm going to use solid dots on this one because I have this equals here. So let me do my y-intercept now. That's going to be this negative 4. So we have 0 comma negative 4, another solid dot there. And then I'll reflect this over the axis of symmetry to get another solid dot. Now the axis of symmetry goes through 2.25. So if I go another 2.25 in this direction, that's taking me to 4.5, if you wanted an exact number there. So now I'll draw a solid line through those solid dots. There's my parabola, there's my border, my fence. And since we have y less than, that means I'm going to shade below the curve, whatever the curve is. So that's all this stuff inside here. Now I'm trying to graph this system of inequalities. So we will just graph each of these individually and then shade a little bit darker where they overlap. So for the first one, these are both standard form-ish. I'll need to make a few adjustments as we'll see, but let's start with that sort of mindset. So let me use negative b over 2a to get the vertex of the first one here. So that's negative, well, even invisible 0 over 2 times 2. 0 over 4 is just 0. And then plugging that back in to get the y value that goes with it, we have 2 times 0 squared. That's just 2 times 0, which is just 0. So our vertex is 0, 0. So let's put that on the graph. That's right there. And then I don't know, so the y-intercept is also 0, so I'm going to have to use another value here. Let's see here, I would use the x-intercepts, but this is also an x-intercept. So what we're going to do instead is just plug in a number close to the vertex, like 1 for x. 2 times 1 squared gives me 2. So we've got 1 comma 2 right about here. And since this is equals under here, these are all going to be solid dots for this particular parabola. So 1 comma 2. And then let's reflect that over the axis of symmetry to get this negative 1 comma 2 point and a solid parabola through those solid dots. Since we have the inequality greater than, y greater than, that means we're shading up, we're shading above the curve, so everything in here. And that's literally half the problem. Let's do the other half now, graph this other inequality on the same axes. I'll start the same way, negative b over 2a. In this case, we've got a b value of 0 over 2 times an invisible negative 1, still 0. And then plugging that back in, I have negative 0 squared plus 1, which is just 1. So this vertex is close to the first one, but it's going to be 0 comma positive 1. So I'll put that on my graph. Since I do not have any equals under this inequality, this is just strictly less than, that means I'm going to use open dots and a dashed line for this parabola. So we've got 0 comma 1 right there, open dot. And now let me get some other points. It looks like the y-intercept is pretty easy to pick out here. We've got y-intercept of 1. Unfortunately, that's also the vertex. So just like I did before, let me go ahead and get some other points. I'll just plug in 1 for this one as well. I mean, it worked for the first one. Why not do it again? So we have negative 1 squared plus 1. That's negative 1 plus 1, which is 0. So that gives us the point 1 comma 0, which is right there. And I'll reflect that over the axis of symmetry to get negative 1 comma 0. Dashed line through those open dots. And then we have y less than, so that means we are going to shade below the parabola here, so everything underneath this blue parabola. And now for the final answer here, that's just going to be wherever these shadings overlap. So that's this little tiny region in here. I'm just going to shade that a little bit darker, and that's our actual answer. All right, we're going to go ahead and graph this system of inequalities. These look a little bit crazy, but you'll see they're actually kind of on the easier end of things to graph because you can kind of tell what values you're using. So these are both standard forms, so we'll start with negative b over 2a to get the x value of the vertex. And I'll just start with this top one here. So we've got negative 4 over 2 times negative 1. That's negative 4 over negative 2, which is positive 2. That's a nice whole number there. Let's plug that back in for x in this first one now to get the y value. So that's negative 2 squared plus 4 times 2 minus 4. So negative 4 plus 8 is positive 4, minus 4 is 0. So then 2 comma 0 is going to be this vertex. So here's a grid, and I'm just looking at this negative 8 y-intercept for my second one, and I'm knowing that I'm going to be down quite a bit here, so that's why my grid is kind of a little bit off-center if you were wondering how I made that decision. So anyway, let's do our vertex. That's 2 comma 0 right here. Now, since this first inequality has the equals under the inequality, this is going to be a solid dot for this first one. So 2 comma 0 right there. The y-intercept on this one is this negative 4. So we have 0 comma negative 4, another solid dot. And let's just reflect that over the axis of symmetry over here to 4 comma negative 4 to get our third point. Solid parabola through those solid dots. We have y less than, so we're shading below that parabola, so that's everything underneath here. And now we move on to doing the next one here. So this is also standard form, so I'll use negative b over 2a again. I'll just spam that as many times as I need to. So that's going to be negative 2 over 2 times the invisible 1. Negative 2 over 2 gives us negative 1. And let me plug negative 1 back in for this second parabola here. So we've got negative 1 squared, which is 1. 2 times negative 1 is negative 2. 1 plus negative 2 is going to be, it's going to be negative 1. And then minus 8 gives us negative 9. So we have negative 1 comma negative 9 for that vertex. Now the second parabola, we have no equals on this inequality. So this is going to be an open dot at negative 1, negative 9. We have a y-intercept for this of this negative 8, so 0 comma negative 8. And that is right up here. And I'll reflect that over the axis of symmetry to get my third point right over here at negative 2, negative 8. Dashed line going through my open dots. The inequality is less than, y less than, so we're going to shade underneath this parabola as well. So that's everything under here. So let's shade all that stuff in. And then the overlapping part is this part that's under both parabolas that I'll shade a little bit darker to get my final answer. For this problem, we're told that a hardwood shelf in a wooden bookcase can safely support a weight W in pounds, provided that this inequality, W less than or equal to 115x squared, is satisfied. Well, what's x? X is the thickness in inches of the shelf. So the thicker the shelf is, the more weight it can support based on this. And it becomes quadratically more. So it's not like a one-to-one thing. It actually, the weight becomes more and more. It grows faster than the inches here. So basically, we just want to graph this inequality in 2 dimensions and then interpret the solution. Like, what does that mean? So for this, we're going to go to Desmos. So here's my Desmos grapher. And in order to graph this, I'm going to have to use y instead of w. So we're going to have y. And then to graph the less than or equal to, I just press the equal to, and then press equal, I press the less than rather, and I press the equals after it. And that automatically gives me less than or equal to. And then we have 115, x, and then we'll do exponent button and square that. So that is our quadratic inequality. So let's zoom in a little bit. Actually, let me change the scale. This is a very steeply growing function, which this 115 out here, kind of makes sense. So let's move the x-axis a little closer. I'll just go from like negative 1 to, let's just do 4. I mean, who has a 4-inch thick bookshelf anyway, right? And then we've got the y-axis. I'm going to make that go from negative 10 to, I don't know. Let's make it 100 and see what happens. All right, so that's a little bit easier to see. Let me make it 1,000 and see what happens. Oh, even better. All right, so we see here that we've got all this shaded stuff under here. Let me just kind of cut and paste that so you can see if I expanded the scale even more what would be happening. So all this shaded stuff under here, these are all the weights, the y values here. These are all the weights that these different thicknesses of bookshelves can support. So for example, at 4 inches, again, I'm not sure who would have a 4-inch thick bookshelf, but if you did, you could support 1,000, even 1,500 pounds of books. So that's a lot of reading material. So let me just write down all that. The solution is just the weights each thickness can support.